Hello everybody, thank you for joining me today. My name is Minim and today we're going to be looking at electric fields. So some of our learning objectives include to understand how to draw field lines around a point charge, to understand the interaction between 2 point charges, between oppositely charged ions and like charges, and to also understand the process of ionization. Okay, so here I have 2 point charges. Now, why am I saying point charges? Well, we just assume that these circles here are an infinitely small point of charged cloud, right? A charged particle, really. So one thing that you need to know is that field lines, so that's these lines with arrows around these charges, field lines always point from positive to negative. Okay, and that's demonstrated by these arrows here. So you can see that these positive arrows are all facing outwards, okay? Whereas all these negative arrows are all facing inwards. And this is a very key point. If you get this wrong, you will not get the marks. Now, another thing that you need to know is that field lines are always perpendicular. So what does that mean? That means that they're always 90 degrees to the surface of the charge, and you should always draw at least 4, but if you have time, draw 8 just to really hammer it home that you understand field lines. Okay, so now let's look at the interaction between 2 different point charges. If I have opposite charges, we know that opposite charges attract. So let's have a look at between our positive and negative charge here. Let's just get rid of these field lines for a second, and let's see how they join up. These field lines look a little something like this. You can see that they bend over. Oh, missed that connector right there, like that, and they go from here to here. Close enough. Oh, also, whenever you're drawing these in your exam, use a ruler. I've done it freehand here, but you must use a ruler. That's a very key point. I can't forget that. I must use ruler, because if they're slightly wonky like I've done them, you won't get the marks. Okay, you must use a ruler to draw field lines. Okay, then between the positive and the negative, I just told you that field lines always go from positive to negative. So the arrow is pointing this way, and this way. Okay, so that's opposite charges. Now let's have a look at like charges. So like means similar. So if we have a positive charge here and a positive charge here, the field lines will do the most they can to avoid each other. Look, we'll get something like this. Can you see that they're not touching each other at all, right? So we have in this area over here the force of repulsion. Let's just call it a repulsive force. Okay, so that's why you can't push together oppositely charged particles, because they just push each other away because of this repulsive force in between the field lines. Okay, now let's have a look at something called the process of ionization. Okay, so let's define it as always. Ionization is the process of removing electrons from a neutral atom. Okay, so let's give a practical example of this. Say I have a power cable running through, okay, and it has, power running through it. Okay, let's label this power cable. If I have an extremely high voltage in here, that means that I have huge amounts of negative charge all around the all running through the wire, right? So this means that I have very strong electric fields, because remember, electric fields it always go from positive to negative. So I see arrows pointing towards the cable. I get very strong electric fields around the cable. My air particle, let's do it in blue. Say I have air particles all around the cable. Okay, air particles. Under normal circumstances, air is an insulator. Okay, so that means that does not allow for charge to flow. But these extremely strong electric fields around the power cable can actually strip electrons away from the air particles, causing them to become positively charged. So let's write that down. Strong electric fields can strip electrons away from neutral particles. Now remember, the absence of electrons means positively charged, so forming positively charged ions, right? That's why it's called ionization, because you're turning these neutral air particles into ions. Now these ions allow for the movement of charge. So this is how you actually get sparks in air, right? So remember when I was talking about static electricity, how we get charge building up on a surface? Eventually that charge, the electric field around that charge gets so strong that it just strips away electrons from the surrounding air, allowing for electrons to jump across that gap to, say, your hand or anything else, allowing for a spark to move. So now you understand the process of ionization.